Okay, so how do we get out of this jam? Well, it's the idea of functors. So in what we've seen about the module system so far, there's an analogy where at the value level, we have types, values, and functions. And at the module level, types are like signatures, values are like structures, and functions are these new thing we'll talk about now that's called functors. Okay, and so why do I make this analogy? Well, you can think of a signature as like a big tuple of stuff, except that stuff is types and values. You can think of values as um, like so signatures are describing a big tuple of stuff, right? So it's like the type int star int is like a signature that has several values like empty and insert and lookup in it. You can think of a value as like actually providing that stuff. So structures are like a big pair of all of the things that the signature defines. And just as functions take values as input and produce values as output, functors will take modules as input and produce modules as output. So the idea for this is that, well, here we wrote two things that if you go back to the last video, look very similar except for their key functions. And so the way we'll make those two things the same is that we'll write a functor tredict that will take as input an ordered type of keys. And rather than having the code say the keys are ints, the fixed type of integers according to the specific type comparison function int.compare, we'll say, hey, the keys are whatever you provided me as input. And so then if we do that, then I don't need to write all of this out explicitly because it's just an instance of what we said down there. So I can grab that and delete all of this, where if I want my int tredict specifically, then what I'm going to do is I'm going to take this functor, right, which is a pattern that says whatever key type you give me, that's going to be the type of keys in this module. And it's going to use that pattern of a general tree dictionary where it says that the type of keys is int and the comparison function is compare. And now if I want my backwards int tredict, well, I can just stamp out the pattern and say that that's the general pattern with the specific structure of keys where I compare things backwards. Okay, so now we've deleted, right? So like the file is now this, we've deleted all the copy and pasty stuff from the last video and just said, well, I've got a general pattern, which is whenever I have a type of keys, K, then I can have a type of dictionaries like that. And now if I look at my example, my backwards dictionary still comes out with 321, and my, let's do the same example forwards. My forwards dictionary comes out as 1, 2, 3, okay, and so on. And so what we're really doing here is we're saying, hey, I've got a pattern. I've abstracted the pattern as a functor, which is a function, a module that takes another module as input, and then we've written an input. And if we wanted to, we could give a name to the input. So we could say structure ints ordered by less than ordered is that struct. And now we're applying tredict to ints ordered by less than. And then we could say ints ordered by greater than is that struct. And then I can apply tredict to ints ordered by greater than. And then the nice thing about capturing this pattern is that now what we can do is we can use any other ordered type we want as input too. So for example, if I want string keys ordered by less than, then all I have to do is make a type T, which is string, and compares the string comparison function. And now I could make a string dictionary by saying it's the general key dict parameterized by string less than. And now if I wanted to flip things around and um, think of the strings as the keys and the numbers as the values, then that's fine. Okay, so now in this dictionary, D prime, the keys are letters and the numbers are values. So I could, for example, do sdict.lookup of D prime, A, and get back 1. Z isn't in the dictionary, so I get back none, and so on. And so for any type that has a comparison function, right, so I could also do some floating points. There, and then rdict is reals ordered by less than, and then I could do rdict.insert of rdict.empty of 2.0 maps to A, and then I've got a dictionary mapping floating point numbers. Okay, so now the point is we've gone back to the state we were in at the beginning, right? If you go way back to the labdict stuff, remember that when we had labdict from last week, you could use any type you wanted as comparison, except you had to show that it had a comparison function. You had to pick a specific comparison function for the type. And what the functor lets us do is it lets us do the same sort of thing as that, except we can give the whole dictionary module the key type all at once with its comparison function, and then have a single comparison function always be used for empty and lookup and insert, rather than passing in a comparison function one by one each time you use the function. And so this will actually let us leverage the type system to find some bugs faster, which we'll see in a second.